Hi, and welcome back to review for the Chem 4 final. How to distinguish an acid, base, and a salt. And I just want to start by saying how to distinguish twins. Come back in. That's my twin sister Annie. And even though we look the same, and we're both people, we have differences, as do acids, bases, and salts. So how do you tell the difference? And we're going to need to know that when we start doing pH problems. Acid, base, salt. Usually an acid is going to have an H at the start. For example, we saw an HCl, HClO3. Usually the hydrogen's right at the front, but if you some stinker problems might give you a problem with the H's at the end of it, like in an organic acid, like acetic acid, which is CH3COOH. Now you remember from our last video, they were sneaky and they put the acid hydrogen at the end. So that's an exception. So acids start with H usually. Bases are usually going to contain, in inorganic chemistry, the group OH. For example, NaOH. Oh, I'm a base. And again, now the exception to the OH will be in the compound ammonia NH3, which has no OH at all. It's not hidden anywhere. Our last type of compound is a salt. A salt's also going to have a positive and a negative, but the positive is not going to be hydrogen. It's going to be any other positive ion, but not hydrogen. The negative component's not going to be OH. It will be a nonmetal or a negative ion. What's a nonmetal and a metal? Remember the staircase on the periodic table? Anything to the left of the staircase is a metal. Anything to the right is a nonmetal. And metals tend to be positively charged. And nonmetals tend to have oxidation numbers that are negative. Now, what do I mean by a positive ion? A positive ion salt could be the conjugate acid ammonium. It could be a metal like NaCl. It could be the positive be a metal and the negative be a negative ion. Anytime you have that positive and negative, but the positives are not hydrogens and the negatives are not OH. And that's how you're going to know a salt. Now we need to know this to do pH problems. And I'm not going to go into detail because we'll leave that for the pH videos. But you're going to be determining the pH of acids, bases, and salts. And to determine the pH, you need the concentration of the hydrogen ions that are in solution. And that's going to be equal to the molarity of the acid times the volume of the acid. No. For a strong acid, the hydrogen concentration is going to be equal to the molarity of the acid times the number of hydrogens in the formula that are acidic. And then the pH formula you memorize is minus log hydrogen ion concentration. And you need to know if the base is strong, and we'll get into strong and weak acids and bases. To find the pH of a strong base, first of all, you must identify it's a base, and that's going to rely on the concentration of hydroxide ions. That's going to be the molarity of the base times the number of OHs in the formula. And when you have a base, you're calculating POH minus log of OH. So these you really should memorize, the pH formulas. And then one more pH formula to memorize before we leave. If you want to change POH into pH, use 14 minus whatever the pOH value is. Remember, regarding pH, now salts can be acid, base, or neutral, so that's a whole other tricky thing. When we're talking about pondus hydrogeni, which is what pH stands for, the power of hydrogen, remember 7 is a neutral pH. Anything higher than a 7 is a basic solution. Anything lower than a 7 is an acidic solution. So keep that in mind when we solve for pH problems, because you know acids are going to have acidic pH, bases are going to have basic pHs, salts, it could be acid, basic, or neutral. Interesting concept. Memorize the pH formulas, and I'll be back with an example of pH of a strong acid.